All right, any questions? You guys can go if you want, but anyone who wants to stay back and ask questions, you're welcome to.
Yeah, I have a question. So while I was going through the lecture notes for the quiz, I had a thought. I don't know if it's a little bit silly, but we were talking about the generators for the manifold structure and the generators, the tangent space and all that. So we had like elements that were close to the identity. And I was thinking about like, so how do we get the elements that are far from the identity? Is there any, what is up with that?
Yeah, you just take your parameters to be large. That's it. But if it's a compact group, then the thing is that you might, depending on how you parameterize your group, you might get back to the same point.
I see.
So yeah, it just like, so for example, if I have, suppose you're thinking of rotation, okay? So this is a very good question actually. So let's take say e to the power I, SU2 to e to the power I T3 and theta. Okay, so this is some sort of, this acts out of, this relates to some, rotation matrix in your SO3, which is rotation around the z-axis by something like this, right? So for theta very small, close to 0, what is this right-hand side? This right-hand side is 1, because you know that for small values of theta, cosine is just 1, right? Yeah. And then the angle is just theta. The sine is just theta, right?
Yeah.
So so this is also 1, 1, right? All of these things are 0. So these are close to the identity, right? This is essentially what the layout. But now if you take theta to be say 2 pi, then you're back to the original point, the identity, right?
Yeah.
Right? So you've gone too far.
So,
but if you take theta to be pi, then you are as further away as you can be, right? But this is very qualitative, right? So this is very qualitative because I haven't really given you a measure of distance, a formal measure of distance, right?
Yeah.
The thing is that you can have a very easily, you can have a formal measure of distance. But before I give you that formal measure of distance, let me give you a very interesting fact, which you know, but you probably don't, you're not thinking about right now, is that if I do, SU2 and SO3 I have the same Lie algebra, but if I do the same thing over here, what is this for small theta? It's going to be e to the power I theta by 2, e to the power minus I theta by 2. This is what this matrix is. So for small values, this is going to be 1 plus I theta by 2, 0, 0. This is minus 1 minus I theta by 2, right? So this is SU2 for small values of theta, right? Now, what if I take theta to be 2 pi, which was like, you came back to the same point as the identity. For SU2, if I put theta equals to 2 pi, what do I get? I get e to the power I 2 pi by 2, 0, 0, e to the power minus I 2 pi by 2. But these 2's cancel, and e to the power I pi is minus 1. So we are not back to the identity for SU2. So for SU2, theta equals to 2 pi is you know, is actually the most distant point you can get. Whereas for SO3, it is the same point. For SU2 to come back to the same point, you have to go from 0 to 4 pi. You just have to change theta to theta by 4 pi. Okay. So this is basically related to that fact that SO3 is basically the 3 sphere with the opposite points identified. Okay. So now let me come back to the formal definition of a distance. So in your tutorial yesterday, I gave you something called a left invariant one form. So this was L of G, and this has some, you know, has some form like that. And you saw that this was a Lie algebra valued, you know, one form. Okay. Now, if I take two of these guys and I trace, say, TA with this guy and TB with this guy, then what I'm doing is that I'm basically tracing over these things. I'm getting a one form, a pure one form. Then you get essentially a function of the angles AB delta theta A delta theta B. Okay, and we take this to be the symmetric product. So then we have essentially what is called a metric tensor. In differential geometry, this is what is used to measure angles as well as distances. So that left invariant one form that I gave you gives you a natural measure of distance on the manifold which is underlying the group. And of course, we also use this to construct the volume forms, right? So if you take the nth antisymmetric product of this thing, this is what it means, and then take its trace, you get the volume form. And the left invariant volume form, which is also the right invariant volume form. So these, you know, there's a lot of beautiful geometry there that you hopefully will learn about someday. Okay, Saib, does that somewhat satisfy your curiosity?
Yeah,